Well, hello. I noticed a little bit of a misunderstanding on how to, at the end of a partial fraction decomposition, integrate something where you had, cx plus d divided by, let's say ax squared plus bx plus c. So you had an irreducible quadratic, and then you had a linear term on top. So what do we do here? What are our steps? The first thing is to let u be equal to that irreducible quadratic. Okay, so then du will be 2ax plus b. Okay. The second step is to force cx plus d to be 2ax plus b, and then the way that you do this is by splitting cx plus d into two terms. Okay. Alright. Do the integral with the 2ax plus b on or in the numerator. Okay. 4 is to complete the square in the integral with only a constant left in the numerator. Manipulate the denominator so that you can do a u sub and your integrand looks like a constant over u squared plus 1 du. Okay? And so those are a lot of steps, and what I'll do is I'll go over an example of how to do that, and then hopefully that'll help you out. So let's erase and do an example. Let's say that you want to evaluate the, so this is after a long process of partial fractions. Let's say you wanted to find, no, this should be probably a 2. Okay, let's say that you wanted to find this integral here. So the integral of x plus 2 divided by x squared plus 2x plus 5. And notice that this is irreducible because what? B squared minus 4ac is negative, so this is irreducible. Okay. So the first thing to do is to split, or is to determine what u would be in a u sub. So allow u to be x squared plus 2x plus 5, and then du becomes 2x plus 2, okay, or 2 times x plus 1. Okay, so then I want to rig the numerator to look like that. Okay, so I need it to be like 2x plus 1, so what I'll do is I'll pull out a 1/2, and that makes the numerator 2x plus 4. Okay. Alright, and all I need is a 2x plus 2, so I'll take the other 2. This will be equal to 1/2 integral 2x plus 2 divided by x squared plus 2x plus 5 dx plus, and then to make up for the other 2 I just put that 2 there, and I get x squared plus 2x plus 5 dx. Okay. Now this one I handle with the u sub I had before. This one I need to complete the square. Okay, so let's tackle the first one. So the first one, u is x squared plus 2x plus 5. So du is 2x plus 2. Perfect. So this is 1/2 integral 1 over u du. Okay, plus your integral that's left over. Alright, so that's the natural log of the absolute value of whatever u is there. So that's good. Alright, and then the second term we just got to complete the square in the denominator and get it to look like something nice. Okay, so let's do 2 birds with 1 stone here. So let's re-plug in what u was. Okay, plus. Alright, so to complete the square in the denominator I take half of this middle term here, 2, and I square it and add and subtract. So I get x squared plus 2x plus 1 minus 1 plus 5 dx. Okay, so then that first term becomes x plus 1 quantity squared by design. That second term becomes 4, or 2 squared. Alright, and so I almost have it. I need a 1 in this position now, so I'll just factor out a 2 from everything. And sometimes this process helps you remember the 1/2 the whole time, but factor out a 2, so I'll get 1 over 2 squared, and while I'm at it, maybe I'll take that 2 in the numerator here and put it there as well. This would be 1. I didn't have 1 to begin with in the x plus 1 squared, so I'm going to have to put it in the denominator. Okay. Now I need to combine the squares. So this is 1 over x plus 1 over 2 squared plus 1, and then I'm finally ready to get my u. So my new u is going to be x plus 1 over 2. So then du is 1/2 dx. So that 1/2 will get rid of this 1/2 here. And so I come to the top. Okay, so this is 1/2 ln x squared plus 2x plus 5 plus, and then I lose the 1/2 there from the u sub, and I get 1 over u squared plus 1 du. Alright, and then some of you missed this in your quiz, but the integral of 1 over u squared plus 1 is inverse tangent, so there's no natural log there anymore. So this is, excuse me, inverse tangent of u, and then finally we're ready to plus a c. Now we just have to plug in what u was. And so we have it. Okay. Inverse tangent of, and then our u was x squared plus 1, or sorry, x plus 1 over 2. No x squared. And that, folks, is your answer. Okay, so there's just one nice example. If you take the time to listen to this, hopefully that'll be helpful.